Every night, as you close your eyes and drift towards sleep, an invisible rain of cosmic messengers passes straight through you, untouched, unnoticed, carrying secrets from the heart of the sun itself. These are solar neutrinos, the universe's quietest whisperers, born in the sun's fiery core, where temperatures soar to millions of degrees. They travel at nearly the speed of light, slipping through the sun's dense layers, through planets, through walls, even through you, as effortlessly as moonlight through glass. For decades, these ghostly particles baffled scientists, vanishing before detectors could catch them, hiding clues about how stars shine and how the universe stitches itself together. Tonight, let their mystery lull you into wonder. Picture the sun not just as a distant light, but as a living, breathing furnace, sending trillions of these elusive particles your way every second. Where are you right now, beneath this silent shower of starlight? Close your eyes and let the story of solar neutrinos carry you into dreams. Now, let's journey deeper into the sun's blazing core, where the story of these ghostly particles truly begins. Picture a place of unimaginable heat and pressure, where temperatures reach 15 million degrees, and atoms are squeezed so tightly they can't resist merging. Here, in this cosmic crucible, the sun's energy is born through a process called nuclear fusion. Tiny hydrogen atoms, the lightest and simplest in the universe, collide with such force that they fuse together, forming helium. But this transformation doesn't happen silently. It releases a burst of energy, along with a flood of neutrinos. Think of it like a bustling factory, where raw materials are transformed into something entirely new. Every second, the sun converts 600 million tons of hydrogen into helium, and with each reaction, neutrinos are flung outward like sparks from a forge. These particles carry away a fraction of the sun's energy, escaping almost instantly, untouched by the chaos around them, while photons, the particles of light, take thousands of years to fight their way through the sun's dense layers. Neutrinos zip straight through, reaching space and Earth in just over 8 minutes. This relentless process has been powering the sun for 4.5 billion years, a constant hum of nuclear fire that bathes our solar system in light and life. And with every fusion reaction, more neutrinos are born, streaming outward in an endless, invisible river. So as you drift towards sleep tonight, remember, you're not just under the sun's light. You're bathed in the echoes of its fiery heart, a whisper of atoms transforming deep in the cosmos. Now, let's follow these elusive particles as they begin their incredible escape from the sun's core. Unlike anything else in the universe, neutrinos face almost no resistance as they travel outward. Picture the sun's interior like an endless maze of superheated gas, where even light struggles to push through. But neutrinos, they glide effortlessly, as if the sun were made of nothing at all. Every second, trillions of them pass through the sun's dense layers, the radiative zone, where energy bounces between atoms for thousands of years, and the convective zone, where boiling plasma churns like a stormy ocean. Yet none of this slows them down. While photons, the particles of light, zigzag for millennia before reaching the surface, neutrinos take a straight shot, racing through like ghosts, walking through walls. This incredible ability comes from their nature. Neutrinos barely interact with matter. No electric charge, almost no mass. They slip past protons and electrons unnoticed, untouched by the sun's crushing gravity or its swirling magnetic fields. In fact, out of the countless neutrinos streaming through you right now, only a handful will ever bump into an atom in your entire lifetime. So as these cosmic messengers leave the sun's fiery heart, they carry with them a pristine snapshot of the core's nuclear reactions, unaltered by their journey. It's as if the sun handed us a secret note, folded so small and light that it travels across space without a single wrinkle, and in just over 8 minutes, that note reaches Earth, whispering the secrets of the star that gives us life. Now, let's peel back the layers of these ghostly particles to understand what makes them so extraordinary. Neutrinos are the universe's ultimate phantoms, so elusive that they can pass through entire planets as if they weren't even there. Imagine standing in a crowded room where thousands of people walk straight through you without a single glance. That's the reality of a neutrino's existence. What makes them so ghostly? For starters, they're nearly massless. A single neutrino is so lightweight that it would take billions of them to equal the weight of a single grain of sand. And unlike other particles, they carry no electric charge, which means they don't respond to the electromagnetic forces that govern most interactions in the universe. No push, no pull, just silent, undisturbed motion. Then there's their bizarre relationship with matter. While other particles crash into atoms or get tangled in magnetic fields, neutrinos slip through everything. A neutrino could travel through a block of lead as thick as a light year, that's 6 trillion miles, and still have only a 50% chance of hitting anything. That's why trillions of them stream through your body every second, leaving no trace behind. But here's the strangest part. Neutrinos aren't just one thing. They shape-shift as they travel. An electron neutrino born in the sun's core might transform into a muon or tau neutrino by the time it reaches Earth. This quantum trick, called oscillation, is like a ghost changing costumes mid-flight, leaving scientists both fascinated and baffled. So while they may be invisible and nearly undetectable, neutrinos are far from insignificant. They're cosmic whispers, carrying secrets from the heart of stars and the birth of the universe itself. And as we learn to listen, these ghost particles might just reveal some of nature's deepest mysteries. Now, let's shift our focus to the incredible challenge of catching these ghostly particles. If neutrinos are so elusive, how do scientists even begin to detect them? The answer lies in some of the most ingenious experiments ever devised, built to capture what seems almost impossible to catch. Take the Homestake experiment, one of the first attempts to hunt solar neutrinos. Deep underground in a South Dakota gold mine, scientists filled a massive tank with cleaning fluid. Yes, ordinary cleaning fluid, because it contained chlorine, which could occasionally interact with a passing neutrino. When a neutrino struck a chlorine atom, it transformed into argon, a tiny change that scientists could measure. But here's the catch. Out of countless trillions of neutrinos streaming through the tank each day, only a handful would ever leave a trace. It was like trying to hear a whisper in a hurricane. Then came Super-Kamiokande, and a detector so vast it could hold 50,000 tons of water, buried a kilometer beneath a Japanese mountain. This time, scientists waited for the rare moment. A neutrino bumped into an electron in the water, creating a faint flash of light. Thousands of sensitive sensors lined the walls, ready to catch that tiny spark. Even then, most neutrinos slipped right through, untouched. The sheer scale of these experiments is mind-boggling. They're built in places where Earth itself acts as a shield, blocking out other particles that could drown out the neutrino signal. And yet, despite all that effort, detecting neutrinos remains like finding a single grain of sand in an endless desert. But every flash, every rare interaction, brings us closer to unraveling the sun's deepest secrets, one ghostly particle at a time. But here's where things got really interesting. Despite these incredible efforts to detect neutrinos, scientists stumbled upon a baffling mystery: the Solar Neutrino Problem. For years, the Homestake experiment and others kept coming up short. They were detecting only about 1/3 of the neutrinos that theories predicted should be streaming from the sun. It was as if 2/3 of these ghostly particles had simply vanished on their way to Earth. This discrepancy sent shockwaves through the physics community. Was there something wrong with our understanding of the sun? Did we miscalculate how many neutrinos its core should produce? Or was there something even stranger happening to the particles themselves? The missing neutrinos became one of the most tantalizing puzzles in modern science, sparking decades of debate and experimentation. Some researchers wondered if neutrinos might be changing form as they traveled. Imagine a chameleon shifting colors. What if neutrinos could transform into types that early detectors couldn't see? Others questioned whether our models of the sun's nuclear furnace were incomplete. The stakes were high because solving this riddle meant either rewriting the rules of particle physics or rethinking how stars work. The mystery lingered for years, pushing scientists to build even more sensitive detectors and refine their theories. Every new experiment seemed to confirm the shortage, deepening the intrigue. It wasn't just about counting particles anymore. It was about uncovering a fundamental truth hidden in the heart of our closest star. And as we'll soon see, the answer would turn out to be stranger than anyone had imagined. Now, let's uncover the twist in this cosmic mystery. The answer to the missing neutrinos didn't come from rethinking the sun. It came from the neutrinos themselves. Scientists eventually discovered that these ghostly particles have a secret talent. They can change identities as they travel. Imagine a vanilla ice cream cone morphing into chocolate, then strawberry, right before your eyes. That's essentially what neutrinos do, switching between three distinct flavors: electron, muon, and tau neutrinos, in a phenomenon called neutrino oscillations. Here's why this mattered so much. Early detectors like Homestake were only tuned to catch electron neutrinos, the type produced in the sun's core. But as these particles raced toward Earth, some transformed into muon or tau neutrinos, invisible to the instruments of the time. That's why the counts were low, not because neutrinos were missing, but because they were hiding in plain sight, wearing disguises science hadn't yet learned to spot. This revelation didn't just solve the solar neutrino puzzle, it shattered long-held assumptions in particle physics. Neutrinos weren't massless, as once thought. They had tiny masses allowing them to oscillate. This discovery forced textbooks to be rewritten and earned researchers Nobel Prizes. Suddenly, the universe's most elusive particles became keys to unlocking deeper secrets, from the inner workings of stars to the very fabric of reality. And so, what began as a frustrating discrepancy blossomed into one of the most profound breakthroughs in modern science. The neutrinos hadn't vanished. They'd just been dancing, all along, in a quantum ballet we were only beginning to understand. Now, let's take a closer look at these three neutrino flavors, electron, muon, and tau, and how their shape-shifting ways deepen the mystery of the sun's hidden signals. Picture them as three siblings, each with their own distinct personality, yet capable of swapping roles in the blink of an eye. The electron neutrino is the one we know best, born in the fiery heart of the sun during nuclear fusion. It's the original, the one early detectors were built to find. Then there's the muon neutrino, a heavier, more elusive cousin, often created in Earth's atmosphere when cosmic rays collide. And finally, the tau neutrino, the rarest and most mysterious of the trio, so fleeting it wasn't even discovered until the late 20th century. What makes these three fascinating isn't just their differences, it's how they blur the lines between them. As they zip through space at nearly the speed of light, they don't stay put in one identity. An electron neutrino might shift into a muon neutrino, then briefly become a tau neutrino before changing back. This constant dance isn't random, it's governed by the delicate interplay of their tiny masses and quantum mechanics. A subatomic waltz we're still deciphering. This ability to transform explains why the sun's neutrinos seem to vanish. Early detectors could only spot electron neutrinos, blind to their muon and tau siblings. It's like trying to count apples in a fruit basket. While ignoring the oranges and pears, you'll always come up short. But once scientists built detectors sensitive to all three flavors, the pieces fell into place. The missing neutrinos weren't gone, they'd simply changed outfits along the way. And here's where it gets even more intriguing. These oscillations hint at something profound. Neutrinos, once thought to be massless, must have at least a whisper of weight. That tiny mass, barely a flicker compared to other particles, is what lets them switch identities. It's a reminder that even the universe's most subtle players can rewrite the rules, turning a solar mystery into a doorway to deeper truths. So the next time you feel the sun's warmth, remember, it's not just light reaching you, it's a stream of ghostly particles, each one a master of disguise, whispering secrets about the heart of our star and the fabric of reality itself. Now let's journey back to the sun's core, where the real magic happens. Deep within that searing, unimaginably dense furnace, the sun isn't just shining, it's transforming matter into energy in a relentless cosmic dance. This is where neutrinos are born, and it all starts with two processes that keep our star alive: the proton-proton chain and the CNO cycle. Picture the proton-proton chain as the sun's go-to recipe for turning hydrogen into helium. It begins when two protons, the nuclei of hydrogen atoms, slam together with enough force to overcome their natural repulsion. One proton flips into a neutron, and in that instant, a positron and an electron neutrino are born. This neutrino, fresh from creation, zips away at nearly the speed of light, carrying a tiny piece of the sun's energy with it. Over and over, these collisions build helium, releasing energy and more neutrinos in a cycle that's been running non-stop for 4.5 billion years. But the sun has another trick up its sleeve, the CNO cycle. While the proton-proton chain does most of the heavy lifting in stars like ours, the CNO cycle kicks into higher gear in hotter, more massive stars. Here, carbon, nitrogen, and oxygen act like cosmic middlemen, helping fuse hydrogen into helium while spitting out even more neutrinos. In our sun, this cycle is like a quiet backup singer, but in bigger stars, it's the lead vocalist. What's astonishing is how much energy these processes unleash. Every second, the sun converts 600 million tons of hydrogen into helium, and with each reaction, a flood of neutrinos escapes untouched. They are the only particles that can race straight from the core to space without getting absorbed or scattered, giving us a pure, unfiltered snapshot of the sun's fiery heart. So when you feel the sun's warmth, remember, it's not just light traveling for 8 minutes to reach you. Those rays began as neutrinos, born in nuclear fires so intense they defy imagination. And every one of those ghostly particles is a messenger, telling the story of how a star stays alive. Now, here's something truly remarkable about these ghostly particles. They're not just escaping the sun's core, they're bringing us secrets straight from its heart. Unlike sunlight, which takes thousands of years to fight its way through the sun's dense layers, neutrinos zip out in seconds, untouched and unchanged. That means every neutrino detected here on Earth is like a tiny postcard from the sun's nuclear furnace, sent in real time. Think of it this way: if the sun's light is a delayed broadcast, neutrinos are the live feed. They arrive with stories of what's happening right now in that unimaginably hot, pressurized core. Scientists can read these stories by catching neutrinos in detectors buried deep underground, where they are shielded from other cosmic noise. Each detection is a clue, proof that the proton-proton chain, or the CNO cycle, is humming along exactly as predicted, or sometimes revealing surprises that tweak our understanding. What's even more fascinating is how these particles act as cosmic truth tellers. If the sun's nuclear reaction suddenly stopped, though they won't for billions of years, we'd know it instantly from the neutrino signal. The light we see would keep shining for millennia, trapped in the sun's outer layers, but the neutrinos would vanish immediately. That's how direct their connection is to the sun's engine. And here's the kicker: neutrinos don't just tell us about the sun. By studying their energy and flavors, scientists can peek into the very rules of particle physics itself. Every neutrino is a tiny puzzle piece, helping us map how matter behaves under the most extreme conditions. So the next time you bask in sunlight, remember, those warming rays are ancient, but the neutrinos passing through you, they're fresh from the sun's core, whispering its secrets in a language we're only just learning to decode. Now, let's talk about speed, because when it comes to neutrinos, they don't just move fast, they flirt with the universe's ultimate speed limit. These ghostly particles race through space at nearly the speed of light, covering the 93 million miles between the sun and Earth in just over 8 minutes. That's faster than you can finish your morning coffee. To put it in perspective, imagine a race between light and a neutrino leaving the sun at the exact same moment. They'd arrive here almost neck and neck, with light edging ahead by just a hair. That's how close neutrinos get to light speed, a staggering 600 million miles per hour. And unlike light, which gets tangled in the sun's dense layers, neutrinos blast straight through, no detours, no delays. This blistering pace isn't just a cosmic curiosity, it's a testament to how little holds neutrinos back. With almost no mass and no electric charge, they slice through planets, stars, even you, as if they're not even there. Every second, trillions of solar neutrinos pass through your body, and you'd never know it. They are the ultimate cosmic commuters, never stopping, never slowing. But here's the twist. Even at these mind-bending speeds, neutrinos still obey the rules of relativity. Time stretches for them just a tiny bit as they approach light speed. If you could hitch a ride on a neutrino, the 8-minute trip from the sun would feel even shorter to you, though good luck catching one. So the next time you feel sunlight on your skin, remember, those rays left the sun thousands of years ago. But the neutrinos, they're fresh off the cosmic highway, carrying news from the sun's core in near real time. It's a reminder that even in the vastness of space, some things move at the speed of now. Now, let's zoom out from the sun and see how these tiny particles shape the grand story of the universe itself. Neutrinos aren't just solar messengers, they're cosmic architects, quietly influencing how stars live, die, and see the cosmos with the building blocks of everything around us. Take a massive star, far bigger than our sun. As it burns through its fuel, neutrinos become the unsung heroes of its final act. In the star's collapsing core, they carry away energy at a staggering rate, like a pressure valve for the universe's most violent explosions. Without neutrinos, a dying star couldn't blast its outer layers into space, scattering elements like carbon, oxygen, and iron across galaxies. That gold in your jewelry, the calcium in your bones, they were forged in these neutrino-driven explosions long before Earth even existed. But neutrinos don't just destroy, they create. In the early universe, mere seconds after the Big Bang, they helped shape the first atoms by influencing how matter and antimatter annihilated each other. Their subtle interactions left behind just enough ordinary matter to form stars, planets, and eventually, us. It's as if the universe balanced on a neutrino's edge to allow life to exist. Even now, as you listen, neutrinos from distant supernova are streaming through you, each one a whisper from a star that died millions of years ago. They're the invisible threads connecting every corner of the cosmos, from the sun's fiery heart to the farthest galaxies. And as we learn to read their stories, we're not just uncovering the sun's secrets, we're decoding the very recipe of the universe. So the next time you look up at the night sky, remember, those twinkling lights owe their existence in part to the ghostly particles you'll never see or feel. Neutrinos are the universe's quiet choreographers, dancing behind the scenes to make the cosmos as rich and vibrant as it is today. Now, picture a star in its final moments, a supernova, one of the most explosive events in the universe. As the star collapses under its own gravity, its core becomes a neutrino factory, churning out these ghostly particles in unimaginable numbers. In just a few seconds, a single supernova can release more neutrinos than our sun will produce in its entire 10 billion year lifetime. These aren't the gentle solar neutrinos we've come to know. Supernova neutrinos are born in chaos, carrying the energy of a star's death throes. They blast outward at nearly the speed of light, helping to rip the dying star apart from the inside. Without them, the explosion wouldn't be nearly as powerful or as beautiful. The same neutrinos that slip unnoticed through Earth also play a starring role in scattering stardust across the cosmos. Here's something even more astonishing. When a star explodes, 99% of its energy isn't released as light or heat. It's carried away by neutrinos. That means the brightest supernova in the sky is actually just a faint echo of the real show happening in the invisible neutrino realm. And these cosmic messengers don't just vanish after the explosion. The neutrinos from ancient supernova are still traveling through space today, some passing through you right now. They're like cosmic postcards, carrying secrets about how stars die and how the universe builds everything from planets to people. So while solar neutrinos whisper to us about the sun's quiet fusion, supernova neutrinos shout the drama of stellar death. Together, they tell the full story of how the universe recycles itself, one ghostly particle at a time. But here's where the story takes an even more fascinating turn. Imagine an entire branch of science, built not around light, but around these ghostly particles. Welcome to neutrino astronomy. Unlike traditional telescopes that rely on photons, neutrino detectors act as cosmic eavesdroppers, picking up whispers from the darkest corners of the universe. These particles don't just tell us about stars, they reveal secrets no telescope can see. Think of neutrinos as cosmic detectives. While light gets blocked by dust, gas, or even entire galaxies, neutrinos slip through effortlessly. That means they can bring us news from places otherwise hidden, like the violent hearts of black holes, or the cores of distant, collapsing stars. Traditional astronomy shows us the universe's surface, but neutrino astronomy lets us peer into its shadowy depths. What makes this field so groundbreaking is its ability to capture events that leave no visible trace. Take gamma-ray bursts, for example, some of the most energetic explosions in the cosmos. While telescopes might catch a fleeting flash, neutrinos could carry the full story of what triggered it. Or consider active galactic nuclei, where supermassive black holes devour matter. Neutrinos might be our only direct link to understanding the chaos happening just outside a black hole's event horizon, and the discoveries don't stop there. Neutrinos could help us map the invisible scaffolding of the universe. Dark matter, the mysterious substance that holds galaxies together. If dark matter interacts with neutrinos in some way, these ghostly particles might finally give us clues to solve one of cosmology's biggest puzzles. So while neutrino astronomy is still in its early days, it's already reshaping how we explore the cosmos. Every neutrino that reaches Earth isn't just a particle, it's a piece of a puzzle, a coded message from the universe's most hidden realms. And as detectors grow more sensitive, who knows what secrets we'll uncover next? The invisible universe is starting to speak, and neutrinos are its voice. Now let's journey to one of the most extreme places on Earth, where science meets the ice in a hunt for cosmic ghosts. Deep beneath the frozen surface of Antarctica lies the IceCube Neutrino Observatory, a telescope unlike any other. Instead of gazing at the stars, it's buried under a kilometer of pristine ice, waiting for the faintest signals from the universe's most elusive particles. Picture this: a grid of over 5,000 sensitive light detectors, each suspended like beads on a string, frozen into the ice. When a high-energy neutrino from deep space collides with an atom in the ice, it creates a tiny flash of blue light, a signal that IceCube's sensors can catch. This setup turns the entire Antarctic ice sheet into a giant neutrino trap, allowing scientists to pinpoint where these particles came from and what cosmic drama sent them racing across the universe. What makes IceCube so special is its location. The thick, clear ice acts as a natural filter, blocking out interference from other particles while letting neutrinos pass through. And because Antarctica is one of the quietest places on Earth, far from city lights and radio noise, it's the perfect spot to listen for the universe's faintest whispers. Some of the neutrinos IceCube detects carry unimaginable energy, billions of times more powerful than those from our sun. These aren't just solar messengers. They are cosmic bullets fired from supermassive black holes, supernova, or even more mysterious sources we've yet to discover. In 2013, IceCube made history by detecting the first high-energy neutrinos traced back to distant galaxies, opening a whole new window into the violent universe. But the hunt doesn't stop there. Every neutrino captured is a clue, a breadcrumb leading us deeper into the cosmos's hidden corners. With upgrades and future detectors on the horizon, IceCube is just the beginning of our journey into the invisible universe, one ghostly particle at a time. Now let's venture into one of the most intriguing mysteries of modern physics, where neutrinos and dark matter cross paths in the cosmic shadows. These two elusive phenomena might seem unrelated at first glance, but scientists suspect they could be hiding secrets that connect them in ways we're only beginning to imagine. Dark matter, that invisible glue holding galaxies together, makes up roughly 25% of the universe's mass, yet we've never directly seen it. It doesn't emit light, absorb it, or interact with ordinary matter in any way we can easily detect. Sound familiar? Neutrinos share some of that ghostly behavior, slipping through planets and people without a trace. That's why some researchers wonder if dark matter particles might be distant cousins to neutrinos, strange, lightweight particles that barely interact with anything at all. Here's where it gets even more fascinating. Some theories suggest dark matter could be made of particles called sterile neutrinos, a hypothetical fourth flavor of neutrino that doesn't even interact with the weak force, making it even more elusive than the ones we know. If these exist, they could solve two puzzles at once, explaining dark matter's hidden presence and expanding our understanding of neutrinos beyond the standard model. Of course, the hunt for proof is anything but easy. Experiments like IceCube and underground detectors are searching for faint hints, may be a rare interaction, an unexpected energy signature, or a pattern in neutrino data that points to something darker lurking beneath. Every time we detect a neutrino, there's a tiny chance it could carry clues about dark matter's true nature. So while we don't have answers yet, the possibility alone is thrilling. Neutrinos and dark matter could be pieces of the same cosmic puzzle, one that's reshaping our understanding of the universe's hidden architecture. And who knows, the next breakthrough might come from a single ghostly particle, revealing a connection we never saw coming. Now let's step away from the lab for a moment and see how neutrinos have danced their way into our stories and imaginations. These ghostly particles aren't just fascinating to scientists. They've also sparked the creativity of writers, filmmakers, and even myth makers. Take science fiction, for example. Neutrinos have become a favorite tool for storytellers dreaming up futuristic tech or cosmic mysteries. Ever heard of a neutrino-powered time machine? Some sci-fi plots suggest these particles could bend the rules of physics, allowing characters to slip through time or communicate across dimensions. It's pure fiction, of course, but the idea taps into something real. The way neutrinos defy our everyday expectations, moving through walls like they're not even there. Then there's folklore. Long before we knew about neutrinos, cultures around the world told tales of invisible forces, spirits that passed through solid objects, or whispers from the sun itself. It's almost as if humanity sensed these particles long before science gave them a name. Today, some even joke that neutrinos are the modern ghosts, slipping through our bodies by the trillions without us ever noticing. Even in video games and comics, neutrinos get a starring role. Some stories imagine them as cosmic messengers carrying alien signals, or as the hidden key to unlocking interstellar travel. It's a playful twist on their real-life mystery. After all, if we can't easily detect them, who's to say they're not hiding something extraordinary? What's beautiful about all this is how neutrinos bridge the gap between science and storytelling. They remind us that the universe's strangest truths often feel like magic until we uncover the physics behind them. So the next time you watch a sci-fi flick or hear an old myth about unseen forces, remember, reality might be even more surprising. Now let's listen to the universe in a way you've never heard before. Picture this every second. Trillions of neutrinos pass through you like silent notes in a grand cosmic symphony. Scientists have found a way to translate these ghostly particles into sound, turning their faint whispers into something we can actually hear. It's as if the sun itself is humming a secret melody, one that's been traveling through space for millions of years. When detectors capture neutrinos, they don't just record data, they reveal rhythms. Each interaction creates a tiny pulse, a blip in the vast quiet of the universe. String these pulses together, speed them up, and suddenly you're listening to the sun's heartbeat. It's eerie, beautiful, and strangely soothing, like the distant chime of a wind chime carried on a solar wind. Some researchers even compare neutrino signals to music. The low, steady thrum of solar neutrinos might sound like a deep cello note, while the sharper bursts from supernova could resemble the clash of cymbals. There's a rhythm to their randomness, a pattern in their chaos. It's as if the universe is composing a song in real time, and neutrinos are the notes we're only just learning to read. What's truly mesmerizing is how this sound connects us to the sun's core. Every note you'd hear in a neutrino sonification is a direct echo of nuclear fusion, the same process that lights our days and warms our planet. So while these particles might be invisible, their music makes the sun's power feel almost tangible, a lullaby sung by the heart of a star. Close your eyes for a moment and imagine it. A shower of solar neutrinos, each one a tiny vibration, together creating a harmony older than Earth itself. It's the universe's way of reminding us that even in silence, there's always a song waiting to be heard. Now let's take this cosmic connection a little closer to home, right into your own body. While you're lying there, drifting off to sleep, something extraordinary is happening. Trillions of solar neutrinos are streaming through you every second, like invisible stardust, weaving through your skin, muscles, even your bones. They don't stop to say hello, and they don't leave a single trace behind. It's the most one-sided interaction you'll ever have with the universe. Think about it. These tiny particles have traveled 93 million miles from the sun's core just to pass through you in a fraction of a blink. And here's the wild part. Your body doesn't even notice. Unlike sunlight warming your skin or the pull of gravity keeping you grounded, neutrinos slip through everything effortlessly. You could be standing in a beam of them as thick as a river, and you'd never feel a thing. But that doesn't mean they're not leaving their mark in other ways. Some scientists joke that we're all walking neutrino detectors, just very, very bad ones. Every once in a great while, a neutrino might actually bump into an atom inside you. The odds about one interaction in your entire lifetime. So while you sleep tonight, remember, you're part of the universe's grand experiment, a living witness to particles that have outlasted galaxies. There's something poetic about that. Even as you rest, these ghostly messengers are stitching a silent bond between you and the stars. They remind us that we're not just on Earth, we're in the cosmos, bathed in the same invisible rain that's been falling since the first stars ignited. So the next time you yawn and close your eyes, picture it, a shower of solar whispers painting your dreams with starlight. But the story of neutrinos doesn't end here. Science is always moving forward, and the next chapter in neutrino research is already being written. Imagine detectors so advanced, they can catch these ghostly particles with even greater precision, peering deeper into the sun's core, unraveling cosmic mysteries we've only begun to dream of. Leading the charge are two groundbreaking experiments, Dune and Hyper-Kamiokande. And Dune, the deep underground neutrino experiment, will be buried a mile beneath the Earth in South Dakota. Its massive tanks, filled with liquid argon, waiting to capture neutrino interactions. Meanwhile, Hyper-Kamiokande, the successor to the famous Super-Kamiokande, will sit in Japan's Kamioka mine, its detector so sensitive it could spot a neutrino's faint whisper from across the universe. What makes these detectors special? They're not just bigger, they're smarter. Dune will study how neutrinos change flavors over long distances, helping us understand why the universe favors matter over antimatter. Hyper-Kamiokande, and with its ultra-pure water and walls lined with light sensors, might finally catch a supernova's neutrino burst in our galactic backyard, giving us a front row seat to a star's death throes. And the discoveries won't stop there. These detectors could uncover hidden properties of neutrinos, like whether they are their own antiparticles, or if they hold clues about dark matter. Every new piece of data brings us closer to answering the biggest questions: how stars live, how the universe evolved, and why we're here at all. So while today's detectors have given us glimpses into the neutrino's shadowy world, tomorrow's machines will pull back the curtain even further. The hunt for these cosmic phantoms is far from over. It's just getting started. Now, let's take a step into the realm of the truly mind-bending. What if neutrinos could bend time itself? It sounds like science fiction, but some theories suggest these ghostly particles might hold secrets that challenge our understanding of reality. Imagine a neutrino not just slipping through matter, but slipping through time, carrying messages from the past or future. The idea isn't as far-fetched as it seems. Neutrinos already defy expectations. They barely interact with anything, move at nearly the speed of light, and can change identities mid-flight. Some physicists speculate that if neutrinos have unexpected properties, like traveling faster than light or existing in multiple timelines, they could open doors to phenomena we've only dreamed of. Think of it like this: if a neutrino could outpace light, even by a fraction, it might arrive before it technically left, a paradox that could rewrite physics. Experiments have even tested this, like the infamous opera experiment in 2012, where neutrinos appear to break the cosmic speed limit. Though it turned out to be a measurement error, the tantalizing question remains: what if we just haven't found the right conditions yet? And then there's quantum mechanics, where particles exist in blurred states until observed. Could neutrinos be dancing across time, appearing in our detectors as echoes of their past or future selves? It's a wild thought, but one that keeps scientists searching. After all, if neutrinos can already do the impossible, why not this? So while we don't have answers yet, the mere possibility reminds us how much we still don't know. Neutrinos might be more than cosmic messengers. They could be time travelers, quietly rewriting the rules of the universe as we sleep. Now, let's peel back another layer of the neutrinos' mystery: their strange behavior in the quantum world. If you thought these particles were elusive before, wait until you see how they play by the rules of quantum mechanics. Picture a neutrino not as a single, well-defined entity, but as a blur of possibilities, existing in multiple states at once until the moment it's detected. This is the bizarre realm of superposition, where particles like neutrinos defy our everyday intuition. Think of it like a coin spinning in midair. It's neither fully heads nor tails until it lands. Neutrinos do something similar, oscillating between their three flavors: electron, muon, and tau, as they travel. But here's the twist: until we measure them, they're effectively all three at once, a quantum cocktail of identities. This isn't just theoretical, it's how neutrinos actually behave, and it's one of the reasons they're so hard to pin down. What's even wilder is that this quantum dance isn't just a quirk. It's the key to solving the solar neutrino problem. When scientists first detected fewer neutrinos than expected, it wasn't because the sun was slacking. It was because neutrinos were changing flavors mid-journey, slipping through detectors unnoticed. Only when we understood superposition could we see the full picture. And this isn't just about neutrinos, it's a window into the fabric of reality itself. The same quantum rules that let neutrinos exist in multiple states might govern everything from atoms to galaxies. So every time a neutrino flickers between identities, it's whispering secrets about how the universe works at its most fundamental level. But here's the kicker. The moment we observe a neutrino, its quantum haze collapses into a single, definite state. It's as if the universe winks at us, reminding us that some mysteries refuse to be fully unraveled. So while we've come a long way in understanding these ghostly particles, their quantum dance keeps them, and us forever on our toes. Now, let's journey even further back in time, to the very first stars that ever flickered to life in our universe. These ancient giants, born from the raw ingredients of the cosmos, hold secrets that neutrinos might help us uncover. Imagine the universe in its infancy, a dark, swirling sea of hydrogen and helium. Then, like a match struck in the void, the first stars ignited, their cores burning fiercely and flooding space with light. And neutrinos, these primordial stars, were nothing like our sun. They were behemoths, hundreds of times more massive, living fast and dying young in spectacular supernova. And just like modern stars, their cores were neutrino factories. But here's the fascinating part. Those neutrinos, flung across the universe billions of years ago, could still carry echoes of those first stellar fires. If we could catch them, they'd tell us how these stars lived, how they shaped the cosmos, and even how they forged the heavier elements that eventually built planets and us. Studying neutrinos from ancient stars isn't just about peering into the past. It's about solving one of astronomy's biggest puzzles: how the first stars transformed a simple, empty universe into the rich, complex one we see today. Neutrinos could be our time machines, carrying untouched information from an era before galaxies, before black holes, before even the first whispers of life. Of course, detecting these ancient messengers is a monumental challenge. They've traveled for eons, their signals faint and buried in the cosmic noise. But next-generation detectors, like the ones we're building deep underground or in Antarctic ice, might one day tease out these whispers from the dawn of time. And when they do, it'll be like opening a window to the universe's first chapter, a story written in the ghostly ink of neutrinos. So while we can't yet see those first stars directly, their neutrinos might still reach us, bridging the unimaginable gulf of time. And in their silent, nearly massless journey, they hold the promise of revealing how the cosmos grew from darkness into light. But let's step back and consider the bigger picture, because neutrinos aren't just messengers from the past. They're silent sculptors of the cosmos itself. Think of the universe as a vast, intricate tapestry, woven over billions of years. Neutrinos, though nearly weightless and invisible, have been threading through it all, leaving their subtle mark on everything from the birth of galaxies to the fate of galaxy clusters. Here's how it works. In the early universe, neutrinos were everywhere, zipping around at nearly the speed of light. Their sheer numbers and energy helped shape the distribution of matter, like an invisible hand gently nudging particles into place. Over time, those tiny nudges added up, influencing where galaxies would form and how they'd cluster together. Even today, neutrinos continue to drift through space, their collective gravity, though faint, playing a role in the cosmic dance of dark matter and visible stars. What's truly mind-bending is that neutrinos might hold clues to one of the universe's greatest mysteries. Why does it look the way it does? The patterns we see in the cosmos, the vast voids and glittering filaments of galaxies, were seeded by fluctuations in the early universe. And neutrinos, with their unique ability to slip through matter without slowing down, carried those fluctuations farther and faster than anything else. In a way, they were the universe's first architects, sketching the blueprints for everything that followed. So the next time you gaze up at the night sky, remember, those distant stars and swirling galaxies owe part of their existence to the quiet, relentless influence of neutrinos. They may be ghostly, but their impact is written across the cosmos in starlight. And as we learn more about them, we're not just uncovering the secrets of the sun or ancient stars. We're piecing together the story of how the universe built itself, one nearly massless particle at a time. Now, picture this: night falls, and as you drift towards sleep, an invisible shower descends upon you. Not raindrops, not starlight, but trillions upon trillions of solar neutrinos, streaming down like a silent cosmic drizzle. Every second, billions of these ghostly particles pass straight through your body, through your bed, even through the earth itself, as if none of it were there at all. This isn't science fiction. It's happening right now and every night. The sun, that fiery heart of our solar system, is singing a lullaby in particles. While sunlight takes 8 minutes to reach us, solar neutrinos born in the sun's core arrive almost instantly, carrying whispers of nuclear fires burning a million years ago. They're the universe's most delicate touch, a reminder that even in the quietest moments, we're connected to something vast and alive. Close your eyes and imagine it, a world bathed in an endless neutrino rain. No umbrella could stop it, no roof could shield you, not that you'd need one. These particles don't disturb a single atom as they pass. They're the gentlest of visitors, leaving no trace except in the detectors scientists built to catch them. Yet their presence is a comfort, a hidden rhythm beneath the noise of everyday life. The sun, ever faithful, keeps sending them, a cosmic heartbeat measured in particles instead of sound. So tonight, as you settle under the covers, remember, you're not just sleeping under a blanket of stars. You're cradled in a neutrino shower, a lullaby sung in the language of the universe itself. And though you'll never feel it, that invisible rain is there, steady, silent, and endless, connecting your dreams to the heart of a star. But here's something even more fascinating. What if these ghostly particles do more than just pass through us? What if, in their silent journey, they brush against the edges of our dreams? It's a thought that dances between science and myth, a whisper of possibility. Neutrinos, after all, are messengers from the sun's core, carrying secrets older than humanity itself. Could they, in some way we don't yet understand, leave faint echoes in our sleeping minds? Think of the oldest stories, the ones where the sun speaks to people in their dreams, where celestial whispers guide or unsettle. Maybe those tales weren't just poetry. Maybe they were glimpses of something real, something science is only beginning to explore. Neutrinos don't interact with matter the way light or sound does, but the universe is full of mysteries we've yet to unravel. Could their constant flow, subtle, relentless, somehow ripple through the quiet waters of our subconscious? Science hasn't found proof, of course, but isn't it wondrous to imagine? As you sleep tonight, bathed in that invisible neutrino rain, your dreams might weave stories under the influence of particles born in a stellar furnace millions of years ago. The sun's voice, carried not by light, but by these elusive, nearly weightless travelers, might just be the quietest lullaby of all, one that hums in the background of your deepest thoughts. And so, as you drift off, remember this: the line between science and myth is thinner than we think. The universe loves a good mystery, and neutrinos, those silent, shadowy guests, might hold the key to dreams we've only just begun to dream. Now let's pause for a moment and consider the quietest conversation in the universe. Every second, trillions of neutrinos stream through your body, enough that over your lifetime, you'll be crossed by more of these particles than there are grains of sand on all Earth's beaches. Yet you'll never feel them, never hear them, never sense their presence in any way. That's the paradox of neutrinos. They are everywhere and nowhere at once, flooding the cosmos while leaving no trace. Think of it like standing in the middle of a vast, crowded train station where every passenger is whispering, but you can't hear a single voice. The station hums with movement, with life, yet to you, it might as well be empty. That's how neutrinos move through the world. The sun alone sends out so many that if you held out your hand, billions would pass through your palm before you could blink. But they don't bump into atoms, don't leave fingerprints, don't so much as stir the air. They are the universe's quietest spectators, watching everything without ever being seen. And yet, their silence speaks volumes. The fact that they slip through solid rock, oceans, even entire planets without slowing down tells us something profound about the fabric of reality. Most of the universe's activity isn't loud or bright. It's hidden, humming just beneath what we can perceive. Neutrinos remind us that absence of noise doesn't mean absence of life. The cosmos thrums with invisible motion, with particles dancing through space since the first stars ignited. So the next time you look up at the night sky, remember, the stars aren't just lights. They're storytellers, sending out silent messengers in every direction. We've learned to catch a few of their whispers, but most of the conversation remains a mystery. A gentle reminder that the universe is always speaking, even when we don't yet know how to listen. But here's the thing, even after decades of study, neutrinos remain one of the universe's greatest enigmas. We've uncovered so much about them, yet they still hold onto secrets that defy our understanding. Take their mass, for example. We know neutrinos have some weight, but it's so vanishingly small that pinning down an exact number feels like trying to grasp smoke. And then there's their eerie ability to shapeshift, changing from one type to another as they travel, a phenomenon that still puzzles scientists today. What's even more fascinating is how neutrinos challenge the very rules we thought governed the cosmos. They shouldn't have mass at all, according to the original blueprint of particle physics. Yet here they are, quietly bending the laws. It's as if the universe handed us a riddle wrapped in a mystery, and every answer we find only leads to more questions. Why are neutrinos so absurdly light compared to other particles? How do they influence the grand story of the universe? We're still piecing it together. And let's not forget neutrinos are everywhere, saturating space, yet they interact so rarely that catching them feels like trying to trap sunlight in your hands. Our detectors, buried deep underground or submerged in ice, capture only a handful of these elusive particles out of the trillions passing by. It's a cosmic game of hide and seek, where the seekers are blindfolded and the hiders leave no footprints. So while we've made strides in decoding their language, neutrinos keep us humble. They remind us that for all our telescopes and supercomputers, the universe still has cards it hasn't revealed. Maybe that's the beauty of it. The more we learn, the more we realize how much is left to discover. Neutrinos aren't just particles. They're a whisper from the cosmos, inviting us to keep listening, keep questioning, and stay curious. Now, let's bring this cosmic journey full circle back to the sun, where it all began. Those ghostly neutrinos, born in the heart of our star, have traveled across space and time to whisper their secrets to us. They are more than just particles. They're messengers, carrying tales from the sun's fiery core straight to our detectors here on Earth. Every one we catch is like a postcard from the center of the solar system, stamped with the signature of nuclear fusion. Think about it. The same neutrinos that dance through the sun's dense layers now pass through you as you listen, unnoticed but ever present. They connect us to the cosmos in a way nothing else can, threading the needle between the ordinary and the extraordinary. And while we've uncovered so much, how they oscillate, how they barely interact, how they defy our expectations, the sun still holds mysteries we've yet to unravel. That's the magic of science, isn't it? The more we learn, the more we realize how much wonder is left to explore. Neutrinos remind us that the universe is vast, humbling, and endlessly fascinating. They invite us to keep looking up, to keep questioning, and to stay awestruck by the brilliance of the stars. So the next time you feel sunlight on your skin, remember, you're not just basking in warmth. You're bathing in a shower of cosmic riddles, each one a tiny spark from the sun's eternal fire. As we drift toward the end of this cosmic tale, let's take one last look at the incredible voyage of these tiny, elusive particles. From the moment they burst into existence in the sun's searing core, neutrinos have traveled an unimaginable distance, racing through layers of scorching plasma, slipping past atoms as if they weren't even there, and finally reaching Earth in just over 8 minutes. They've carried with them the untold stories of the sun's deepest fires, stories we've only begun to decode with our clever detectors, buried deep underground or beneath icy landscapes. These ghostly messengers remind us that the universe is alive with mysteries, humming just beneath the surface of what we can see. Every second, billions of them pass through you silent, invisible, but undeniably real. They're a gentle reminder that even in the quietest moments, we're connected to something vast and wondrous. So as you settle in tonight, let the thought of these cosmic travelers lull you into rest. Picture them streaming down like stardust, a quiet shower of sunlight from millions of miles away. Close your eyes and imagine the sun's whispers, those tiny neutrinos keeping watch as you drift off. The universe is full of wonders, and tonight, you're part of its grand, beautiful story. Sleep well, under the glow of these eternal messengers from the heart of our star. If you enjoyed this journey through the mysteries of solar neutrinos, don't forget to hit like, subscribe, and ring that notification bell so you never miss another cosmic bedtime story. Sweet dreams, and keep looking up.